taking a look at our probability and stats exam review. A couple of notes that you need to be aware of, because on the in-class exam for probability and stats, you'll get a couple of questions that deal with things like a deck of cards or something like that. So just by a quick review, a standard deck of cards has 52 cards in it, and I believe I mentioned that. That is mentioned actually on the exam. There are 4 suits. There's hearts, diamonds, spades, and clubs, and there's 13 cards of each type in the suit. Okay, so that's just one thing that you need to be aware of as you go through. Okay, we'll start off by taking a look at some experimental probability, and experimental probability is given to us right here. Okay, so experimental probability, it's the total number of successful trials divided by the total number of trials. So a trial is every time that you attempt to do something. Okay, and so in an experimental sense, you're actually doing the experiment. You're not basing it strictly on its theoretical probability, you're doing it based on the number of actual times it happens in the real world. So in our first example, we'll do the experimental probability of what does actually happen during the trial. And so here we have on the right-hand side, we've got a table of values for rolling a 6-sided die. Okay, and we'll roll this die a certain number of times. We want to figure out, well, how many times do we get these results over here? Okay, so first thing that we want to do is we want to figure out, well, what's the total number of rolls that each thing happens. So here we've got 3, 3, 4, 7, 4, and 5. So first thing you need to do is you need to add up all of these numbers together in order to get the total number of rolls that we've got in the situation. So we've got 10 plus 11 plus 5. So there are 26 rolls in total, okay, in terms of the number of rolls that were done. Okay, so if I add 3 plus 3 plus 4 plus 7 plus 4 plus 5, that gives me a total of 26 trials. Okay, and so the first thing that we want to figure out is, what is the probability of getting, in this case, getting a 4? Okay, so that P just means what's the probability of. So the probability of getting a 4, and we always want to express that as a fraction in lowest terms. So in order to get a 4, this is the result, the number that it actually, so the result is the number you actually roll, and the frequency is the number of times you get that result. Okay, so the probability of rolling a 4 is going to be right here. Okay, so I rolled a 4 7 times. So 7 out of 26 times I rolled a 4. And then in order to turn that into a decimal, I would take 7 divided by 26, and then I'd multiply that by 100. So approximately 27%. Okay. So 27% of the time I ended up getting a 4. The next question here is the number of times you get an even number. Okay, well, even numbers are 2, 4, and 6. Okay, so the number of times I get an even number, that's going to be, I rolled 3 2s, plus I rolled 7 4s, plus I rolled 5 6s, for a grand total of 15 out of 26 rolls were even numbers. So again, if I wanted to convert this into a percentage, I would take 15 divided by 26, and I would multiply that by 100. So I'm going to do 57 decimal 7%. Okay, so approximately 57.7% of the time I got an even number. The next example here is a number that is greater than 3 or even. Okay, so a number that is bigger than 3 or even. So 3 is not bigger than 3, but numbers that are bigger than 3 are 4, 5, and 6. Okay, so greater than 3 is 4, 5, and 6. And even includes number 2. Okay? So my even number is right there. Okay? So if I add the total numbers of those, I would get 5 plus 4 is 9, plus 7 is 16, plus 3 is 19. So 19 out of the 26 rolls, I rolled a number that was either greater than 3 or an even number. And so again, I would take 19 divided by 26, multiply that by 100, and that's going to give me approximately 73%. And then lastly, it says, what's the probability of rolling a number greater than 4 and even? Okay. If it's, again, the key here is the word and. And means that both things have to be true at the same time. So numbers that are greater than 4 include 5 and 6. Both of those are greater than 4. However, only the number 6 is even. So therefore, only 5 out of the 26 times did I roll a 6. 6 is the only number that is both greater than 4 and at the same time it is even. So therefore 5 of the 26 times I rolled a number greater than 4 and even. Okay, and if I convert that into a percentage, it's going to give me approximately 19%. Okay. The big issue there is you need to be able to distinguish between or and even, okay, and identify which pieces that you're needing to collect. Or could be either one, uh, and means both conditions or all conditions have to be happening at the same time.